Okay, so we've talked about SpikeRS, and we referenced quotas when we were talking about SpikeRS. We also referenced them a bit when we were talking about products. And if you remember, when we looked at our product, there was some values that we set for quota for a particular product. Well, now that we have those values set, we can actually create a policy now that references those values and then restricts access to your APIs based off those quota values. So to do that, we're going to go ahead and add a quota policy. Under new policy, there's quota. I'm going to call mine quota by product. Now the reason I reference by product is because by default, well, it's not even by default, but you know when you set those values on your quota, you think about setting those proxy restrictions at the product level. But it's not restricted to just the product level. It's also, you're also able to set those limits at the application or the developer or even an IP if you wanted to. And the way you do that is because the product itself, the quota itself is not necessarily tied particularly to a product. It's tied to variables. And those variables can be defined and referenced within the policy specification. So when I create this new policy, you'll notice that there are several fields here. And you'll also notice that a lot of them have references to values. By default, it's referencing header values. We're not going to use these header values. We're going to actually reference the values from our product. Now, to do that, we're going to do a couple of things. First thing we're going to do is, so I've added this, I'm going to save it. I'm going to trace, and since I already have a trace here, I'm just going to reuse this trace value and populate those references with the values that were associated with the product that I was associated with. Now, and you'll notice here on the values that they actually match those values that we set on the product. So when we look at this, we can actually see these references here. In this case, we're going to match interval with the variable that I copied from that trace, the verify API key, verify underscore API key dot API product dot developer dot quota dot interval. That's a very long string of variables. The way that it works is you're referencing the type of policy, which is verify API key, then the name of the policy, which is verify underscore API key, then API product, then developer, quota, and then the interval. Now, I'm going to go ahead and copy the rest of those over. Great. So there's a few things that you need to know about the quota policy. There are 3 types of quota policies that you can put into place. There are calendar quota policies, rolling window, and flexi, which I'll go ahead and explain 2 because the third one is the same as rolling window. So flexi is pretty much the same as rolling window. I actually really personally have not figured out what the difference between those 2 types are. When we talk about rolling window, the idea about a rolling window is that the timer for how long you have to retain a certain amount of requests in your bucket starts when you make the first request. And this is the most common use of the quota. The second is what we call a calendar. What a calendar does, it says, at this point, I want you to start the window and rotate the window on that point every period of time associated with your quota. So if you had 100 requests an hour and you defined the noon hour as the start, it would then, at that 0 noon hour and that 0 minute, it would start that quota, and then no matter how many requests you make in that, it'll rotate that every hour on the hour. For the example that I'm going to do here online, we're going to use rolling window. And you can change the type as an attribute of the quota policy itself. Now, there is a field that only relates to calendar, and that's time, the start time. And if you're not doing a calendar, you do not need a start time. And the start time is where you define when that quota starts. Now, there's a few other fields, and the other fields have to do with error rate. The error rate at which you want to accept for performance reasons. Distributed quotas add latency because they need to keep all the servers in sync. We're a very distributed system. So to keep all the servers in sync, it's going to be synchronously updating each of those servers. So when you go full synchronous distributed, you can add some heavy latency, especially if you're talking about a DN environment where you're going between multiple regions in the ecosystem. Now, that is the 100% error rate. There's 100% non-error rate. You're going to get, if you do 10 requests per minute, you're going to see 10 requests per minute. You'll never see 11 or 12. It'll always be 10 per minute because they're synchronous. It's not going to allow it to update without updating those servers. Now, if you want a more performant system, the most performant way is to turn distributed off and then double or multiply the number of requests in your quota based off the number of message processors in your environment. That could be tricky in the cloud. This is kind of an on-premise versus cloud scenario. On-premise, you know exactly how many servers you are, and you can then rotate between your servers and then multiply, and you can do that arithmetic on your servers, and it's not a big deal. But when you're in the cloud, you could be scaled, and you could have another server added, and then you'd have to change all your quota arithmetic, and that might not be a good thing. But it is the most performant way of handling it. Now, there is a middle road, and that's where we talk about asynchronous updating of the quota. Asynchronously, you can set the configuration to synchronize the requests coming into the quota syncing between the different servers on a period of time. And you can also set the number of requests that it's going to sync at a time. And depending on how your data set up and the number of requests in there, you can actually get really close to the perfect world, but not necessarily have the issues with latency that you would normally have with the full distributed. It's a very good way of synchronizing without incurring the cost of the extra latency. So for this example, we're going to go ahead and say distributed is true. And that means that it's going to synchronously update everything. If we set synchronous to true, if we set synchronous to false, it's going to use these asynchronous values. In this case, we're going to go true, true. The asynchronous configuration at this point will be ignored because we have true and true. If synchronous was turned all false, it would actually use these asynchronous configurations that are below to figure out how to sync in the background. So now we've added a quota policy. And you can test a quota policy by making a few requests to your backend. So I set mine to 5 per minute. So about the 6th or 7th request, we should see, there it is. On the 6th request, we saw a violation of the quota. Now, one of the items that you don't see me connecting to is there is the idea of an identifier. An identifier allows you to identify the actual request coming in. In this case, it would be the API key. And once you have the identifier, you've actually localized on the specific application for your quota. So now we actually have a quota that is limiting the requests to our backend at a rate of 5 per minute.